before I head off for the night, let me give you guys another shear plane, if you will. All right, these clowns, they're stuck over there, and they keep trying to ask the same question over and over again, how, and that's because they're refusing all the data. All right, this is in tension, as I told you guys. It's not in compression until they start reclamping. Now it's reported that they finished reclamping. Again, I'd like to see the crane operator's statement on this, that he moved this thing back and forth. The amount of revolutions, 50 kips per time. Total of at least, 11 revolutions? Maybe 12 however you count when you start counting to one. From one, rather. All right, so you have this in the deck. This is in the deck over to here. This is outside the deck, right? I showed you guys many images of this. This pulls from the deck. This pulls outside from the 12 column. This is number 12. Remember, it's pulling outside. So this is stationary. They both have the equal amount of clamping force, if you will. Being the same amount of kips. Let's call it 288, whatever it might be. But this one's staying still in the deck. This one's coming across the deck. They're not pulling equally together, because one's outside the deck and one is inside the deck. This is out in that little blister, if you will, and it only has to get to the part of the deck that becomes the secondary part of the design. Meaning, if you follow this line across, this is where these two uprights sit on top of the deck. So this is the deck, this line here, followed across, but let it meet this line here. This is the other part. So as this comes across, as you can see, this would be totally embedded in the deck. And then all this stuff sits on top of the deck, everything from here up. Let me do this for you. Let me pause it and let me grab something for you. Give me a minute. Okay, good. So when I'm going to grab this with it's called markup. So I'm just going to grab a little pen here, and this is the line, right? So it goes here, and it comes down. So this is your deck. I think I can change it to that. This is your deck area, and as you can see, this force are going this way. So let's just grab a little thing here. Oops, it changed my marker. Okay. So one more time, let's go back to red then. So that's the force there. This force is going, this is the J-bar. We see this in great shape. This force is coming up here like this. All right. Oops. That's what it shows. Let's see if it gets, okay. It's going up here like that, creating all it has to do to create a failure is just across that plane there. Just knock this off and it's outside the deck. This is all that's inside the deck. This little bit of area here, which is this. Well, let me make it clear for you. Let's do this one more time. Grab another one. It's just this area right here that's left. That's outside the deck. It just needs to knock that off. This is all fair game here. This is where these members are different. And let's grab it. So this looks like this. And it will look like this then, right? So now you guys see it. So this is the member in here. This is all of this. Okay. But this is already stationary right here. This is being stationary. This one's already creating a force here. We already know that the cracks exist. It came down this already when they attempted to reclamp. Doing so, there's nothing left. There's nothing left to reclamp to. It's already sheared off the deck. If you remember the images, we have the deck being sheared off right about here. Right about here is our deck. So there's nothing really to reclamp. The forces are reapplied through here. It just clearly 280,000 pounds of force can just blast right through here. While this is still stationary, we have photographs of this still in place. While this is still in place, this just goes right on past it. That's how you're able to get, this also is leaning inwards and rocking out, as I've stated. But this is a major thing here. This part here just you see how what's going on here? They're trying to say that this moved off. As I grab this, they're trying to say this slid off. This slid this off. How you see what's going on there? This can't go through. Here's a bar, stationary. Let me get you that again. Let me put that back over there. So here's the bar. If this tries to go through there, the whole member's got to slide. It can't do that. The whole member they're all connected. So let's do this. Let's delete that. Let's grab that one. Let's delete it. And let's grab a new one. And now let's look at it, this capacity. They're saying this slid off by being pushed by this number 11. Oops. So if it's sliding, what's happening to this one? We know this one's in the deck. It can't move. This one's also clamped in at the canopy. It can't move. So all of this entire member has to go through these two huge 1 3/4 inch diameter rods that can take 280,000 pounds of force. They have to go through there. It's not going through there. It's not the way the failure happened. We don't see it crushing and tearing up the entire back of this. In fact, we see this member still in place. That this section is all that's missing from the bottom of 11. The rest is in place. So if the rest of it's in place back here, how can you get this moving over? Well, you can't. You can't do it. You can't get there from here, as a guy might say. So yeah, I just find it the most stupid thing ever. Let's now do this. Let's make this member move over. So this is the member again moving over, pushing off 12, but it comes in contact. So you can see it can't punch through this. So that didn't happen. It can't punch through because again it's got to go through these rods. These rods for these people's formula to work, they got to be removed. All of this stuff has to be removed also. And nobody can explain the perfect condition of this. How is that perfect condition? If I were able to get this to flex, that rod looks like that, right? There's that rod. If I'm pushing against that rod with this member, would I not be bending that rod up at this point? Would that rod not look bent? And let's get rid of the rod. Would the rod not look like this? With a huge bend in it, as this would have to push through it. And as you're doing that, do you see what happened here? How is this embedded in concrete and created shape? This would be deformed. It would be crushed up at that point. This one would start to crush up. It would look, if you're trying to bend that rod, it would look, it would crush back on itself. It would close up. Yet that rod looks perfect. So if I try to push this, that's going to do that. All right, so this is the most important part there. What's another version of how do I break that rod? How do I keep that rod in perfect condition? Slide everything off. Well, they have it shearing going down this direction. That it's shearing going down. That's the same thing. If you push that rod through that concrete, if you push it through the concrete, it's going to crush up. It's going to deform. It's not going to stay that perfect condition. So you have to have, you can't have any pushing, pulling, or anything on this. This has got to be pretty much a free break. And to do that, I have this action initially of it going down, breaking free, the concrete in here acting as little shims after it had that first initial moment. There's initial braking around here. We need braking all the way out here, and it looks similar to the crack that we observe. It keeps this in place. We'll get rid of that, and we'll get rid of this and that one, and we'll go ahead and write a new one. So it sort of looks like this. We can see that member there. So we can see all of this. So this is what we can see. And it goes like that. This is the part that's missing. This can only jack up so much because it's destroyed here. We see it being pulled over though. It's being pulled off. So the break is happening in two sections here. That's all that's happening here. Watch this. As the canopy is being pulled off, going down, this is a nice little break. It just pulls it off in tension, breaks it off free in tension. During that dramatic, first you had that initial breakdown, so that just made you get rubble here. And then when you now change this, it just lifts off. That's how we're getting this perfectly rod and everything else. We need it to lift off. It's lifting off. You can't have it going that way, but if you do that, you're going to bend this rod. And once you bend that rod, you now can't get the shape. So I got 11 minutes in this. I just want to show you the lift off. You lift this off. You got perfect access to this rod. The J-bar is shown, everything. The J-bar is now able to, all this is now visible. All this is visible and perfectly okay. But you just simply need this to lift off. You do that by the canopy, lifting it off, pulling it off. And you see where the rotation is up here, where the braking is, all up here above the cracks. Lift off. All right, I'm terminating the video. Have a good night, everybody.